Hello, Tom from EveryStepCalculus.com. This is Lagrange multipliers, and you can see the problem there on the screen. I'm going to show you how my program works on this, okay? We got index 8 here to get to my main menu after you download my programs into your computer and then download them into the calculator, the TI89 calculator. I'm already at Lagrange here but you'd scroll down in the menu to get to here, okay? I'm doing that to save time with the video here. Press enter. And we're going to choose X, Y, and Z because that's what this problem is, X, Y, and Z, okay? So number 2. You can press the number or scroll down, whatever you want. I've already entered these functions into the calculator here to again save time. X squared times y squared times z squared. After you entered it, I always give you a chance to change it in case you messed up or made a mistake. I say it's okay. I'm going to choose number 1, and we're going to put in the constraint. Here's the constraint. I've already added that. X squared plus y squared plus z squared equals 1. And again, we're saying that's okay. And then we start doing the partial derivatives of the function. You notice with times, with respect to x, you're going to have 2x and then put down the other 2 like it is. So we have 2x, 2 times x times y squared times z squared, okay? Now fy would have 2x squared is x squared actually is kept, and then we have 2 times 2 times y, and of course the calculator brings the 2 out in front here in when you multiply functions together or terms together. And then we have the z squared. Same thing with z squared here. It's 2 times z, and then we keep the 2x squared or the x squared and the y squared together, okay? We do the g of x, turns out to be these here, adding lambda to the terms, and we have our system of equations. So we take the change of f x y z equals the lambda times change of g x y z, just like this, just what we found each individually before. Here they are. Now we're going to, in this system of solving the equations, we're going to multiply both sides times x or y or z, which will make the left side equal, okay? And if that's equal, then these have to be equal to each other. So this Lagrange is kind of a trick thing. As you can see here, we're going to divide out the 2 pi, or 2 lambda, come up with x squared equals y squared equals z squared. Well, if that's true, then x squared equals x squared equals x squared also, which we do here. And that's 3 times x squared equals 1, x squared equals 1/3, x equals the square root of 1/3, plus or minus square root of 3 over 3. Same thing with the y. Notice the nonsense of this Lagrange. All calculus is nonsense as far as I'm concerned. Solves nothing useful. Never has, never will, because it really can't. It deals with functions, and functions have to be round, nice and neat, and parabolas and circles and spheres, and we don't need to find anything about those things, okay? So anyways, we have that. So then x, y, and z is equal to what we found here, plus or minus these. And when you take a square of a square root, you get 1/3 times 1/3 times 1/3. And that cubed is 127, which is the global maximum, okay? Now, because any x, y, or z, as we can see in the constraint here, if we have 0 of any one of these, the whole function is going to be 0. So therefore, 0 is the minimum value. Okay. Pretty neat, huh? Everystepcalculus.com, everystepphysics.com too. Go to my site, buy my programs. They're only $40, and you'll pass calculus. Otherwise, you can study this crap like I have. This has taken about a month for me to program all this stuff, the variations, and working maybe 2-3 hours a day on it, and figuring out the best way to do these things. You know, each person that tries to answer it has a different type of system, but anyways, I found the correct one, and here it is. Okay, so enjoy passing calculus with my programs. Okay. Hey, have a good one. Good luck in your classes.